Question 13a. Use the substitution u equals cos squared x to evaluate the definite integral from x equals 0 to x equals pi over 4 of sine 2x over 4 plus cos squared x dx. Here are the marking guidelines for question 13a. For 1 mark, we have finds du dx or equivalent merit. For 2 marks, we have finds correct primitive or equivalent merit. And for 3 marks, we have provides correct solution. Starting with the substitution u equals cos squared x, we could rewrite the substitution as u equals cos of x all squared to make the differentiation a little clearer. Now we have a composite function, which means the chain rule will need to be applied. So we find the derivative of the outer function, which is the squared function, and we multiply that by the derivative of the inner function, which is cos of x. Hence, du dx is equal to 2 cos x multiplied by negative sine x, which is equal to negative 2 sine x cos x. And multiplying both sides of this equation by the differential dx, and then dividing both sides by negative 1, we have negative du is equal to 2 sine x cos x dx. Therefore, negative du is equal to sine 2x dx, since sine 2x cos x can be expressed in terms of the double angle for sine. Now, sine 2x dx is the numerator of the integrand, and that's going to be replaced with negative du eventually. The next step is changing the limits of integration. So when x equals 0, u equals cos squared of 0. So that's using the substitution. Substituting x equals 0 into the substitution u equals cos squared x, u equals cos squared of 0, which equals 1. And when x equals pi over 4, u is equal to cos squared pi over 4, which equals half. Hence, the definite integral from x equals 0 to x equals pi over 4 of sine 2x dx over 4 plus cos squared of x is equal to negative du over 4 plus u from u equals 1 to u equals half. Now, to make the integration a little easier, we can reverse these limits, and to compensate for that, we could multiply this integral by negative 1. So rather than having a negative integral, we now have a positive integral, but instead of from 1 to half, it's now from half to 1 of du over 4 plus u. And the integral of du over 4 plus u is ln of 4 plus u, from u equals half to u equals 1. And applying the limits of integration, that equals ln of 5 minus ln of 9 over 2, which equals ln of 10 over 9. The following is the feedback from the Marking Centre. Students should apply their knowledge of calculus, algebra, and arithmetic to evaluate a definite integral. In better responses, students were able to differentiate u equals cos squared x correctly, substitute correctly for u, change the bounding limits and place them in the correct positions, and integrate and substitute correctly to arrive at the solution. Areas for students to improve include avoiding common errors such as providing the correct integrand, using the original limits, providing the correct integrand but placing the limits incorrectly, differentiating incorrectly, making errors with negative signs, and avoiding careless substitution errors.